Well, welcome to Beginners Academy, our Zoom meeting. We have talks every other Monday on topics for beginners and returning hams. Tonight, our talk is on vertical antennas, and one of our attendees had a question about counterpoises and radials. And really, my title is clickbait, so we'll see how it flies. I'm Greg, N4KGL, and I'm in Dothan, Alabama. All right. Well, the basics here for beginners, I always recommend building their first antenna. The one on the left is a dipole, and it's probably one of the simplest antennas for amateur radio. And it's for cut for the band that you're interested in, like 20 meters would be a band you could cut it for, or any of the HF bands. The formula for the half wavelength, the cutting formula, is 468 over the frequency in megahertz. And each half would be a quarter wave, which I think is 234 over the frequency in megahertz. So for 20 meters, the antenna is 32 feet long. And of course, technicians have privileges on 10 meters. So I think it's only about 16 feet long. I'd have to use the calculator. And my diagram leaves out a balun. When I started in amateur radio, I didn't know what a balun was. And as my friend Tom will tell you, this is how we build antennas, and they work just fine. But the general practice now is to put a balun between the coax and the antenna. All right. Well, the dipole, if it's horizontal to the earth, is horizontally polarized. And the polarization goes along with the electrical wave, so to speak, and along the element. So if it's horizontal, it'll be horizontally polarized. And if you turn this on its side, it'll be vertically polarized. Over on the right is the famous do-it-yourself antenna for usually it's popular for 2 meters, and it's called a quarter wave ground plane antenna. And the vertical element for 2 meters is about 19 inches long, and so are the two elements drooping down there, which is the ground plane. Of course, a lot of times it will work with just two ground plane conductors, but you also see it with 4. Well, anyway, what makes it so cute is it can be built from a SO239 connector. So, well, going back to the dipole, dipole is essentially a self-contained antenna. It's tuned for one band. It has a frequency that you cut it for, and it has 2 parts. And Antennas, whether we call them dipoles or verticals, require two parts. So the radials or counterpoise, and I'm going to have to admit that I looked up the definitions, and frankly, there's not much, there's no difference of significance. So both of them are similar. You can build a counterpoise with radials, but maybe your counterpoise is a screen, and that wouldn't be radials. Um, so on the vertical, the elements B, labeled B, are the other half of the antenna. But how you satisfy the other half with a vertical can really vary. All right, well, this slide has a lot of variations of the vertical antenna. On the far left is a vertical dipole, just the dipole we had on the first slide, turned vertically. The black dot is the feed point, and that's a way to implement a vertical. And where things get a little different is when you, so that vertical dipole, each is two elements, each is a quarter wave. Okay, I'm going to move over to the ground mounted vertical. The element is a quarter wave, but the other half of the antenna is radials. It's basically the ground, which is improved with radials, wires. They actually can be buried a few inches under the surface. They might just lay on the surface. And if you put them out in your yard and tack them down, the grass will grow over them. You won't know they're there. So, but that is referred to as a ground mounted vertical. And a monopole is just a fancy name for that quarter wave. It doesn't have to be a quarter wave, but often it is. Next to that is the elevated vertical. And it can have radials, also known as the counterpoise. And in that case, they may be tuned radials, maybe exactly a quarter wavelength, or they could be a different length. We'll talk more about that as we go. And we'll cover all these in more detail. Of course, on the far right is our friend, the dipole, which could be used with a single support with the ends hanging down. And we generally refer to that as an inverted V dipole. So I talk about many variations. Well, there are hundreds of variations on these antennas for different situations and different construction. But electrically, they're the same. All right. Well, we'll focus in on the ground-mounted vertical. You can have multiple elements in your vertical, which the one on the left does. It's the equivalent of what we call a fan dipole, but it's with a quarter wave for the different bands. And those quarter wave conductors will be of different lengths. And having a ground-mounted vertical has certain advantages. And with your radials, either underground or under the surface, takes up less space in your backyard. You may have to dig up your yard, but but
Hey,
actually you don't have to dig up the yard.
hey, Greg.
Yes, Jim.
Yeah, that one on the left there, that's what I have, but I have 8 radios on mine. It's an 8 band.
Yes.
And I
Well,
have 16 radios in the
uh,
ground.
uh, there's certain sadistic people that suggest more and more radials.
I have 16. That's enough.
Yeah,
By the time you get through
uh,
burying them, you worked all
that
day.
I agree. And so don't take the 60 radials literally. And,
That's once I got past 8 of them, I didn't see much
yeah,
gain.
Eight would probably be just fine.
yeah,
Yeah, but also
yeah,
it all has to do with the type of soil you're working with too.
it does.
If it's
Now,
if it's sand, you might need it
yeah,
more. But up in Cleveland, the soil down there has iron and all kinds of
yeah.
other stuff in it that makes it more dense.
Well, what you find is there is a lot of engineering on the subject, and perhaps there are charts showing that the more radials you have, the more efficient your antenna will be. But um, uh, if you just, it's just how seriously you, well, it's how much efficiency you want. And for a general amateur radio, you're not going to have to go to what the commercial broadcast stations do, which is 120 radials. So, so those are good comments that you'll see different suggestions about how many radials, and certainly in the neighborhood of 8 or 16, it is far more reasonable. Over on the left is kind of a technical diagram, and it turns out if your antenna was over a perfectly conducting surface, um, it effectively is like a dipole, because a mirror image of your antenna, it acts as though there's a mirror image of your antenna, which really makes it a dipole. But it's not physically going into the ground. It's implemented by your grounding system. So I'm going to try not to get too deep in the weeds.
Well, I can add a little bit here.
Yes.
On mine, since I transport it from Cleveland to here, I just clamp mine to my cyclone fence, and I have a 200 foot cyclone fence, and I just clamp it on there
Yes.
and take off.
And you're using your fence as a counterpoise.
Right.
Right. So for Frank, that's the other half of his antenna, which that makes it pretty easy. It's
Yeah.
good enough for most ham
It,
radio
it,
purposes.
it
Yeah.
goes up. I take it down in about a half hour,
Yeah.
and then when I go back,
Well, there are, there are people who take it very seriously and go to the full extent to get the most efficiency possible. But those are people that are interested in DX or contesting, or just, are perfectionists perhaps, but
too
to each
much
his
time on
own.
her.
All right. Well, this diagram, well, the reason I like it is it shows that, well, whatever, if you have a ground mounted system, you're going to induce currents in the ground, and your ground, your earth, the soil, its conductivity will vary, but nevertheless, it's not a great conductor. So it's kind of like little resistors. And as you see in this diagram, we have resistors uh, on, underground. They're just representing that the resistors, which can produce loss. In other words, the currents are turned to heat, and so that's what reduces your efficiency. This diagram has to do with displacement current, which you really have to be a student of Maxwell's equations to understand. And I'm still struggling with that. All right, well, getting more practical here, you could come up with a elevated radial vertical that's just wires and hang it from a tree. And that's what we've got on the left. So that would be a very expensive antenna, inexpensive. And the radials are, I think they're varying the length a little bit because they're turned down. I forgot to mention, if we went all the way back to that first ground plane antenna, the radials are at an angle, and the reason they have them at an angle is to get a better impedance for matching 50 ohm cable. And it just turns out in this situation, it's convenient to have them at an angle. So the verticals usually have lower impedance, but changing the angle of the radials helps. Over on the left, this is the kind of antenna Chris likes. I believe it's, it may or may not be, but a telescoping. You can actually, in particular for portable use a telescoping element. And I'm getting a message that Chris, I'll let Chris get in here because he might want to tell us about his antenna. Are you with us, Chris? Well, he'll catch up with us.
Well, since he's coming from Canada, it take a while to get
Yeah,
here.
it could take a while. All right. Well, actually, with a telescoping element, you can change the length to have it work on different bands. And in a portable situation or in your yard, you could stretch out elevated radials, which Chris likes. You can also let them lay on the ground, which will still work. All right. Are you with us, Chris?
What's that on the right there?
Well, it's
Is
as
that-
close to what Chris uses for an antenna that I could find a picture for.
Oh, that's not yours?
No.
Oh,
No.
okay. I was wondering what pole that is there.
Yeah. Well, Chris uses a telescoping.
Yeah, I
Yeah.
use the MFJ 1979, I think is the model. It's a 17-foot web.
Yes.
There's a few on the market though.
Yeah. So that's what Chris, it's his go-to antenna for portable operations.
Works just fine. I don't know what's wrong with my
Okay.
camera.
All right. Well, it just happened. I jumped over on eBay and I found, well, actually, I saw a video by Alpha Echo 5 X-ray, I think. And he was doing POTA and he was using this antenna. And this is the eBay listing for it. And it is a telescoping element, similar to the MFJ, but it collapses to a shorter length. So it's a little easier to pack. The fellow that did the video rides a motorcycle, so it fit in his little boxes or saddlebags or whatever. And the other thing this comes with is a spike. So you could put the spike on the bottom of that red object there. Well, actually, you'd probably drive the spike in first and then screw on the connector there. You would put your counterpoise wire on and then put your collapsible element. So this was, I believe, less than $50 free shipping from China. So I ordered one. So we'll find out how good
Greg,
it is.
Does that look like ribbon cable that they're using for the radio?
It looks like it. Pretty much anything would work.
Yeah.
Is that just the insulator, or does it include the whips?
It includes, it's one whip and one spike. The spike is for mounting it.
I
to the
imagine
earth.
what you find is that the that ribbon cable is cut at different sections, so that one is 5 meters, then 10 meters, then 15, then 20.
Yeah.
So it's quarter wave on the different bands.
Well, you can actually roll up the extra length, and it won't hurt anything. Well, we'll find out. I'll give you an update when this comes in.
Greg, how much
What's in that?
If I'm not being too personal.
Go ahead, Wes.
Oh, how much was it if I'm not being too personal?
I think it was under $60. I don't remember. It could have been under $50.
Yeah, I would hope so.
Yeah. Well,
What is the red object?
well, it's basically an insulator, but it lets you, it handles connecting the center of your coax connector to the top element. That's
To the whip.
basically what it does.
And the spike.
Not
Yeah.
a balun.
It doesn't have a balun in it that I know of. So,
Gotcha.
300 watts.
yeah, I don't know. Well, it was relatively cheap. How about that? Now, actually, Chris, tell them where you got your little connector and section there.
Yeah, it's what I use is just a meant to be on a semi trailer's rear view mirror. So you get them at the truck stops, and it's called a 4-way clamp thing that'll clamp onto the rear view mirror for the semi trailers or any pipe. So I don't know. Can I share a screen there, Greg?
Yeah.
Although you're recording here. I'm running some other software on my computer and it is just bogged down. I'm recording meteors tonight. Actually, I should have turned that off.
Okay.
Anyhow, there we go. So, I probably got a better picture of it.
Oh, that's pretty good.
There we go. So it's 4 stainless steel bolts, 2 plates of aluminum. This plate of aluminum can go vertically or horizontally, depending on what kind of pipe you're clamping it to. You tighten up the 4 stainless steel bolts, and then you end up with a, oh, that's the wrong picture. That's one of the hazards I've got out here. There we go. That's a better one. Yeah. So there's the 4 bolts tightened up, and then you end up with a 3/8 by 24-inch thread, much like that one that Greg's got. It's got the same thread on it, I'm sure. So what fits into that is the ham stick, the Hustler, the MFJ telescoping whip. It's all kind of a standard from the CB industry, I think, from the CB antennas. And at this end, where my index finger is an SO239 plug. And like the one that Greg got, Greg's is on the side, mine's on the bottom, and it's offset with this bit of an L bracket. And then you just plug your PL259 cable in. So it all amounts to exactly the same thing. But you can pick these up at any truck stop for around $15, I think, and they're pretty good. It's anodized aluminum with stainless steel hardware. One thing I did found is if you are putting a counterpoise on it, I use an alligator clip and different lengths of wire. Don't clip it onto the aluminum. The anodization creates quite a bit of resistance. I was quite surprised. Instead, put it right about where my finger is there. Get a larger alligator clip and put it right on the PL259 connector itself, which is usually nickel plated, or if in the case of I don't know if Jim's here, you might have silver, plated PL259 connector. Anyhow, I put it right on the PL259. You get a better electrical connection. I find the aluminum is kind of putsy, and that's it. And then I got this on a walking stick here. You can put it on anything, a rail on your boat, or on anything on your travel trailer, any kind of vertical pipe or horizontal bar. You can clamp it on, and away you go. So that's
And your fence post.
or your fence post, yeah. And you can see it's got both of them got grooves in them, so they'll clamp on horizontally or vertically. Like I said, it's a real versatile thing. And any of the large truck stops that have got the CB gear, on the back wall and the pegboards, you'll find them there. It's pretty handy. I got one clamped onto a camera tripod, and I run two legs a little bit longer, and the leg that thing is on, I put it a little bit shorter, and it's almost vertical. Frank, have you got the same thing in your hand there?
Well, I have
Yeah, same idea.
Well, this is a tripod from a drum set.
Yeah, I was going to say music set. Yeah. Yeah, and
and
there's
then
the same.
I
Is that the same bracket, Frank?
I-
I'm going to stop a share here.
Well, I got this for counterpoise if I need it. And then here,
Yeah,
I
that's the
have,
same deal.
PL259, now I have this other thing that I can screw on top of here and convert it over to a 3/8 24 thread. And it's this little gadget that converts it to that.
Oh yeah.
That goes on here, and that enables me to. But if it's just this, I can put like a 2-meter mobile, use it for 2 meters. With this, then I got.
Now you can put a hamstick on it.
Well, I got this thing that I made, and it's plexiglass, and I have it drilled so I can screw it on here this way. I can screw it on like this way, or I can even screw it like that, different ways. And then on top of here, I have these things that are.
Yeah, that's the 1979 there, right?
Yeah, this is the 10-foot version.
The 10-foot, yeah, that's a different model.
I can put that on here on one. I can put this one over on the other side. And I got a V configuration. And then I could even send this out 10 feet, and I can clip a piece of wire from here over to here, and I'll have like a triangle.
Well, really, yeah, it'd be a delta loop practically. Yeah.
Yeah, delta loop. Now,
Yeah.
I can put it this way too, and it'll be directional because it'll tend to go that way. So this thing here, all it is, I have a lot of this plexiglass, real thick, a 7/8. And I drilled it and I have it tapped this way, so I can screw it this way. I can screw it this way, so it's that way, or that way, and a lot of different ways. And then I have this thing here that comes off of there. This just converts it over to coax. And if I want to use a ballon, MFJ makes a ballon, and then this just plugs into the ballon. If you want to use like a 4-to-100 ballon. So with this, I can configure a lot of different ways. And
Versatility.
then the whole thing
That's-
fits in a little
that's
pouch
your-
that I carry it.
That's your Versa widget. That's
Yeah,
awesome.
that's what it is.
All right.
A Versa widget. Yeah, that's in Spanish.
Well, Jimmy, I think you picked up on the internet that some people are using a Faraday blanket for a counterpoise. Is
Yes.
that the name of it?
Yeah, well, they call it a Faraday cloth.
Faraday cloth.
Yeah, or fabric.
So that would be a counterpoise. It's not really radials, but implements the same thing. It's the other half of the antenna.
It's,
So-
it's
Yeah, well,
taking place of the screen. People have been using window screens,
Yeah.
and it does the same thing.
Yeah.
Well, that gives you a lot of capacitor conductance. I mean, coupling. So it acts like a giant capacitor against Earth there. And
Yep.
that does the job. That would be like the same thing as you would have a car. When you put a whip on a car, the car will make an image of the antenna, but also couples you to ground through the metal being close to the ground. That has a certain amount of
Yep.
capacitors coupling too.
Yeah. I have a slide on that coming up.
Oh,
Well,
okay.
that's exactly right. Yeah. All right. All right. Well, I think the only thing different about this is we'll just see how good that collapsible telescoping whip is. And it was supposedly shorter than the MFJ one, so it might be easier to pack. All right. Well, this isn't, I stole this slide, but basically, we've talked about a quarter wave antenna, element for vertical, and I kind of equate that to full size. When you shorten, say, a quarter wave was 16 feet, but you shortened it to 8, then there's some impact to that. It appears as a capacitor, basically. So to match it, you would need a inductor in series with it, and that's actually pretty popular. It's called a loading coil, and but there's two sides to the story. One is when you put a coil in, actually, well, one thing, a shortened antenna in regards to wavelength has reduced what they call radiation resistance. Okay, so you're matching to a lower value of resistance, and it's capacitive also. And when you use a coil or a capacitive hat, well, in particular, a coil has loss in it. So, so it kind of hurts you two ways, being short, and then whatever matching you do has loss. So it's the bottom line, it's reduced efficiency. Now you can look at that two ways. You know, if you want a more perfect antenna, you'll use one that's full size. But if you want to get out and play POTA and have something shorter, you can have a shortened antenna. You can have a coil, and it will work. But just it is not as efficient as a full size antenna. So we won't dwell on that too much because for me, if you're making contacts, then your antenna is just fine. And on the left is a loading coil, and there is an outfit called Wolf River that makes these coils. And for example, well, the antenna Chris was talking about with that MFJ telescoping whip, it is pretty much full size for 20 meters, and you wouldn't need a coil. But if you wanted to use it on 40 meters or 60 meters or 80 meters, then you would need a coil. And so Wolf River would love to have you use one of theirs. And it has a little slider on it to adjust it. So you would adjust it for the best match. And it's very popular. Now over
Yeah,
on
I've got two of them. Don't ask me why, but I got
yeah,
two.
I've got one too that I really don't use. So but actually I think Wolf Rivers started out making coils for mobile antennas, and now they're popular for the antennas you'd use in the park. There's a lot of sources for the coil, and yes.
That I may add in, you can tune it by sliding that up and down, giving it more coil, but you'd also tune it by moving the telescoping whip can be moved up and down to give it a fine
Yes,
tune.
good point. Now over on the right, it's just showing you a portion of the antenna, but there's a popular antenna called DX Commander. And I know that one of our members have, I guess, made one or bought one and modified it. But basically, it has a pole and then a system of rings on it that will let you use a different length of radiator for the different bands. So that has one advantage, that you don't have to change any settings. Once you got it set up, you don't have to change any settings. With the coils, if you went from 60 meters to 40 meters, you would probably need to move the slider. So it's just something you have to deal with. And also the elements are full size for the DX Commander. And if you go on YouTube and search for DX Commander, you'll get to know Callum over in the UK. He's a very popular YouTuber and manufacturer of the DX Commander, and he keeps evolving it and improving it. I don't have one, but they are available at DX Engineering. So
hey, this is Ken.
Yes.
I have one of his poles, and the quality of the stuff is just top drawer.
Yeah.
And you can order it directly from him. And I think I got my pole within less than a week.
Yeah.
So I wouldn't fool with DX Engineering. I'd just go straight to Callum.
Yeah. Okay. All right. Well,
Hey,
you
Greg.
can,
Hey, Greg,
yes, Jim.
on the DX engineering, you can build that same thing for about 1/3 what he's selling
Yeah.
it for. I
Always.
mean, you know, if you wanted everything where you don't have to do anything but open up the
Yeah.
box and put it together, okay. But if you can go down to Lowe's and order you a telescoping flagpole and stuff like that, you can
Yeah.
build that for about 1/3. I built mine for less than he sells it for.
Oh,
Although I
yeah.
had one of his to start with. That's where I got the idea
Okay.
from.
Well, that's a similar thing with almost all the antenna manufacturers. They generally do a great job and use quality parts and have it all set up, but you have to pay for that convenience. So, but if you're a DIY guy, you can save a lot of money and
A
have
lot
some
of fun too.
and have a lot of fun. Yeah. But anyway, check out his YouTubes. There you go. Now, Frank, this is your slide right here. Go ahead, Frank.
Well, yeah, what you got here is a magnetic vertical, and this antenna really relies on capacitor coupling because it doesn't make metal to metal contact. And over here you got what do you call it? A buddy set. What do you call those sticks that are with the thing wrapped around it?
Ham stick is one name.
Yeah,
Yeah.
a ham stick. And then basically the body of the car here will duplicate what that is. So you end up with a dipole, and the body would be the other half of that. And then on top of that, the car itself is couples to the ground. But this particular one that's just held up there by magnet, it relies on having electrical ground through the coax, and that I would try to avoid that because um, it's going to be an uncertain ground. It's going to vary because you don't have an electrical connection between the metal of the car and that. Basically, they started making these for CB, but
Yeah.
the CB band and the whip had to be 17 feet because the coax, because the coax acted as a counterpoise. And a lot of people make the mistake of trying to put this on that, and just in order for it to really work well, the counterpoise needs to be a direct metal contact with the car.
Well, it's probably better, but
Yeah,
a lot
I
of
mean,
people use the mag mount and get on
yeah.
well,
Well, with this type of antenna, because it's spun like that, it tends to react a little different than just a straight whip.
yeah. Well, if you rent a car, you can throw the mag mount on it and start making contacts.
So Frank, couldn't you just take a piece of wire with an alligator clip like Chris was talking about and put it on the coax and clip it to the car, to the frame?
Well, you could, but that alligator clip and that length of wire is not going to be a direct contact. That length of wire would actually be looked at as an extension of the antenna.
Yeah. Well, they have trunk mounts and other mounts that do connect
Luggage,
to the metal in the car if you can pull that off. Yeah. Yeah.
luggage rack too.
Yeah. Well, the people who are into operating mobile actually do they have a few tricks to play to get a much, basically the better your ground, the better your efficiency. And so So they bond bond different parts of the car together to make sure it's just all one low impedance path. So, but a lot of us don't go to that kind of trouble. So all these subjects we're talking about, you can go really deep and learn how to make optimum system. But for a lot of us, a simple solution is good enough for making your POTA contacts. So, or even better than that. Chris is also a fan of the ham sticks. and
Yeah, I
uses-
just
yeah,
that or the Hustler. I just got
Yeah.
started on hamstick. I bought you can get a kit of like 5 of them from 80 meters up to 10 meters, and then different whips, and they all fit into a case for a fishing rod, one of those breakdown fishing rod cases. So it's real easy to
Yeah.
move around.
Hey, Chris, what's your opinion about this setup here with
I did a mag mount for a while. I found once you got 20 meters on up, it would usually work. 40 meters and below,
yeah,
you didn't have enough coupling. I played around with a jumper wire like Jimmy suggested. Then I tried a capacitor jumper to the ground of the car, and that got me through 40 meters working okay. What I did in the end, though, is I ended up strapping right to the body of the car itself. The other thing about the mag mount is if you're moving and you hit any kind of a branch or a big semi goes by the other way and you get any kind of movement, you can damage your paint. So
I'm
I'm
laughing. Yeah,
searching through
I-
my stuff and see if I can find a picture of my mount that I got on my car.
I drove down to the club one night, and it happened that street had a low limb, and it knocked my antenna and the mag mount off.
Yeah. So
But bear in mind, this does not work with the later models of Ford F-150.
yeah, I would
aluminum ones.
That's right.
No, all you need is a aluminum magnet.
That's all I need.
Yeah.
Yeah.
Oh yeah.
Called
Yeah.
super glue.
All right.
I believe
Duct tape, duct
it would
tape.
work quite well on my VW bus.
Yeah.
German steel all the way.
Well,
Get
really,
that Gorilla duct tape.
this is popular for POTA. You might not want to drive down the road with it, but
No.
you can just have the mag mount up there and screw in your ham stick and make your activation. So it's cool.
One of the things I mentioned, and that would be getting into like screwdriver antennas. That a lot of people get, for example, the Yaesu version of the screwdriver antenna, and they just can't get it to work, and here just they don't realize that the base of it has to go to ground directly immediately. You can't have wires or nothing, because then the wire would be looked at as part of the antenna itself. So that if you got a screwdriver antenna, particularly the Yaesu one, unless you got a direct metal contact immediately at the base, you're going to have problems getting it tuned.
Yeah.
I found my picture of my mount for an SUV or any hatchback car if you'd want to have a look. Can I share a screen there, Greg?
Yeah.
See what I'm doing here. Oh, someone else is sharing? What is it telling me?
Not
here?
now. I just
There
stopped
we go.
sharing.
Okay, I think this is Frank Brown Park in Panama City Beach. So there it is there. But let me go to next slide where you can get a better picture of it. And there it is with a stick on it. I like to angle my sticks back. Number one, if you do hit that low branch that you didn't see or the low bridge that you forgot about, it's already partly tilted. So it kind of does less damage to the antenna if it's already bent back. Number two, I find a lot less wind noise with it back 30 degrees like that. When I had it straight up, I could hear it whistling as I was going down the interstate, but tilted a tiny bit back, the wind noise basically disappeared. The third thing is, I don't think it affects the performance at all. I've been out on the lake where I can drive around and around in a circle, and I've done on more than one occasion tests on 20 meters, 15 meters, and 10 meters. And I told the guy what direction I was pointing as I was talking. So I said, okay, I'm going north now. Now I'm going east. Now I'm going south. Now I'm going west. Now I'm back to north. And asked him, did he see any difference in his S meter? None at all from anyone that I've ever talked to. So that's a zoom in on what we're looking at. So you open it.
Yeah.
Sorry, go ahead.
That's what I wanted to see, was how you had it attached. Okay.
Yeah, so this is with the hatch open. So on most cars, when the hatch goes up, there's a bit of a gap there. So this is, you get this 1/8 aluminum at Lowe's or wherever your favorite hardware store is. And I cut it about 6 or 8 inches long. I bent it right about here. Sorry for all the tape. And then I put sheet metal screws in here. And I put a bit of bedding on there first. I put a bit of silicone seal in between this metal and this metal, because this metal is not 100% flat. It's called bedding in sailboats. I don't know what it's called in the automotive industry, but the silicone seal gives it more of a uniform bed to sit on. I think gun makers do it with the forestock and the barrel of a rifle with fiberglass. But anyhow, I used a silicone seal. You let the silicone seal set up for a day, and then you crank all your screws another half turn, because once it's set up and solid, now you finish tightening your sheet metal screws. The beauty of this is, if you go to sell the car, you undo the screws, you peel this thing out, you put a drop of touch-up paint on each of the 3 screw holes, and no one's going to look up there, right? That's up in when the hatchback is closed, that's all covered up, right?
Yeah.
So it hides it beautifully. That's the other side. I had 2 of them running. I had one on one side, one on the other. So that's on the right-hand side of the car. And there's the first one is over on that side of the car. And there's another picture of it. And this is the that's not an SO239, although you can get one. I use just the bolt head, and then the 3/8 by 24. So you can get these again at your truck stops or at any kind of a radio store too.
Hey, Chris.
Yeah.
Also, they make springs that will fit between your whip and your mount.
Yeah, I thought of that too, but with the aluminum has got a bit of flex to it. There's a better shot of the whole thing. There's a bit of flex right there, and there's lots of flex in the ham antenna. And this thing can almost go horizontal without breaking anything. And I'd say you'll get, and hitting a bunch of trees, which I do a lot of because I'm on bush roads here, I'll get 3 or 4 years before this aluminum is fatigued to the point where I got to change it. And if I do have to change it, I use the first one as a template, and I can make another one up in 20 minutes, bolt it in, and we're done. So yeah, just 3 sheet metal screws. You got to make sure that the screw is flush enough that when the hatch closes, it doesn't get caught by the rim there. But generally speaking, most of the cars have got enough clearance that you can go through. Now, what about the cable? The cables come down. This is, again, a dual setup, one on each side of the car. You don't need to do that. One was sufficient. I bring it down, and then I bring it back up. And that way, if the water is on this side when it rains, right? So if the water comes down, it's going to drip here, and then it's going to drip down into the tailgate region there and not come up into the car because it's not going to fight gravity. So this is a drip loop, basically. And then it comes down here, then under the carpet, through the back seat, under the carpet on the back passenger's floor, and then up under the passenger seat. And then I put the radio. I don't drive while I'm moving anymore, so I just have the radio sitting on the transmission hump or something up there in the front. There's a better view of it. Yeah, there you can see comes down the gutter. And this gasket on the tailgate is usually the thickest gasket in the car. The ones on the side windows and stuff, they're pretty tight. You try to get a mini RG8 Mini X through there, and you can get some wind noise. But the one on the back I find is very pliable and cushy, and it's the easiest one to get through. And there you have it.
Chris, do you have an
Okay.
issue with co-phasing those antennas? Do you,
No, I run them on separate bands.
oh, okay.
So I'll have a 20 meter and a 15 meter up, let's say, depending on what time of day I'm driving. Or if it's at night, I might have a 40 and a 20. And then I have an A/B switch in the front of the car. And if one band's going dead and I'm not bothering to stop, I'll just flip over the other band. On my current car, I've only got one on one side, and I just get out and change the stick. But this is when I was a little keener, and I would have one on each side. And boy, if you got two black antennas sticking out the back of your car, and you pull up behind someone on the highway, they think it's a cop for some reason. I mean, cops haven't used those long antennas for like 40 years, right? But everyone go, oh my God, I'm being watched by, and they'll slow right down to the speed limit. It's a real pain in the butt, actually. But that's how I do my mobile mounts. I've done that on three cars in a row now, and that aluminum plate screwed right into the body of the car. I mean, it's a perfect ground. You don't have to worry about 80 meters, 40 meters, 20 meters. It all works just grand.
Awesome.
Hey, Chris, regarding your directional of vertical in your car,
Yeah.
if it's like this and the bulk of the body's this way, it's going to favor that way. But by tilting it, it's going to have a equal attraction, so you're going to end up with an equal amount in all different directions.
In theory,
Because
yes.
the metal-
In theory, yes. But like I said, I've probably done it half a dozen times on ice, in parking lots. I've done it going down highways and doing a 90-degree turn. And I say, hey, can you hear any difference between now? And then I go around the turn and now. And they say, no, they're watching their S meter. They're getting ready for it. They say, absolutely not one S unit difference. So yeah, I think you might have a dB or two. But at a 30-degree tilt, I would say it's not measurable at the other person's end. Not to be worried about. I thought so too, Frank. I thought it'd be a huge difference. And when I first did it, I was shocked. The guy says, I hear nothing. No difference at all.
Yeah. Right. I found pictures of my vertical on my cyclone fence. Can I share that?
Yes. Just a minute. Go ahead.
All right. Well, this is how I got it clamped on to my cyclone fence. That's one view. Here's the other view. This is my a 4-to-1 awning, and this particular wire goes to the antenna itself. The other one just goes to the metal. This metal is clamped to the pole. If I go back over here, you'll see it. This goes to the antenna, and of course the antenna is isolated with this plastic here, and this is clamped real tight to that. And then this whole cyclone fence is well, I would say is a total length of 200 foot long. And then so if I go to here, that's what it looks like in my yard. And this is this antenna is 43 foot vertical with another 8.5 foot width on top of that. So it ends up being about over 50 feet altogether. And then I got a current balance right about here. You may not see it. It's just a coax through a ferrite donut. 5 turns one way, and then it goes across and 5 turns the other way. And that eliminates the RF from getting back into my house. And it works well. I tuned this with the C11 Pro 2 tuner, and I can tune it from 80 all the way up to, well, one of the things is that by using this balun, the core will not let you transmit above 30 megahertz. But if I feed it directly without the balun, I can tune this to 6 meters. But some of these cores are made only for HF. And that's about it. Let me stop sharing.
Awesome. Well, I appreciate the sharing here. Let's see. Oops. All right. Okay. Well, we'll continue. Well, the same principles apply to random wire antennas. And my friend Tom, who's with us, uses this kind of configuration for HF with his QRP rig. And now this, I call it random. This people use all kinds of different lengths, or maybe they don't even know what the length is, but nevertheless, most lengths will tune with your tuner, and the two 25-foot radials are the counterpoise. So this is kind of what we call a non-resonant antenna, but by using a tuner, you can make it, it will present a good impedance to your rig, and or a low enough SWR that your rig will put power out to the antenna. So this other half of the antenna applies to this kind of operation too. And so I guess it's a little early, but the one thing hopefully I'm trying to convey is you do need the other half the antenna. And if you don't provide something, it will try to find it. So it may go through you or find some other path to the ground, but probably you won't have a very good SWR. You might have a lot of RF floating around if you don't provide a counterpoise.
Yeah, I was going to mention that earlier when you talked
Yep.
about just making it work. SWR number 1, and then ask the guy how's your audio number 2. That if you've got
Yeah.
both of those working, then you're whatever you did is working. Don't change it. But that's what I said. Like when we were with Dennis at that Deer
Right.
Park, SWR was good. Everything's looking good, and we're doing parks on the air. I'm really happy, and everyone's saying, "No, it sounds like you got RF in your audio real bad." And the second counterpoise, like you had in your diagram there, made all the difference in the world. All of a sudden, everyone's
Yeah.
saying,
Well,
audio's clean now." So, and you just don't know. Like it, sometimes one works, sometimes you
yeah.
need 3, whatever. You just try it until it works.
Yeah. Well, I'm going to roll through a few verticals that I've used. As a novice, I got a lot of help from my mentors, so I didn't pick it out, but the antenna installed in the yard here was a high gain 18 AVQ ground mounted vertical, which is probably 25 feet tall. And it it had 4 ground rods. Now, almost nobody recommends using ground rods alone, but the 4 ground rods were about 6 inches from the little pipe it was installed on. And I worked the world, you know, got all those QSLs from Russia, all over Europe and all, with just, you know, the 4 ground rods. And I later found out what radials were, and I installed some radials on it. And it, you know, it may have made a little difference. But the other 2 antennas here there's a manufacturer of antennas called Buddy Pole, and their first antenna is a Buddy Pole that is a dipole with 2 arms. It's designed for portability, and there's a loading coil in each arm. And you would mount it horizontally, and you would have a shortened dipole in a portable situation. Well, they took basically half of that system and called it a buddy stick, and it's a vertical. And their recommendations was to use 1 radial, and I did this. This was my first. These aren't my exact antennas here, but it was my first portable antenna, and it worked great. But bear in mind, I was running QRP levels, and sometimes that helps you get away with things. But nevertheless, so it came with basically a 33-foot wire with a winder on the end, a kite winder, and you just adjusted it to an appropriate length for the band that you were on, and you adjusted the coil and whatever necessary to get it to resonance. And it's a popular, and the instructions recommend, or it comes with 1 radial. You could use 2 if you like. And over on the actual picture on the right, the radial runs out to a little stick. You can lay it over bushes or have a little they have these push-in poles for not tents, but fences. But 1 point we can make about this is that if you're going to have a resonant counterpoise shooting for a quarter wave, then you'll want it to be elevated off the ground at least, 8 inches, a foot, or 2 feet. And I believe that's what you do also, Chris. And that's going to be the most efficient. I have actually, with different antennas, long wires and things, I have used a counterpoise laid out on the ground, and it works. It may not be as efficient as it would be if it was elevated. Well, I went on a work trip to Tampa, Florida, and this is the buddy stick, but instead of vertical, it's horizontal. And I strapped it to the rail on the balcony so it didn't fall down and hit anybody in the pool down there. And the counterpoise I've been talking about, I had it hanging down from this balcony. So I could have also pulled it back into the room, but well, it made it interesting to have it hanging down and for people to look at dancing outside their window. So, but anyway, this worked fantastic. I've used this configuration at other hotels, either from a balcony, or if you can get the window open, you can stick it out the window. I did this in Italy, so forth. But so
Were there any waffles harmed in this experiment?
no waffles harmed.
Okay.
No,
Oh.
but it's very convenient to have Waffle House out there. Okay, well, now there's something called Pedestrian Mobile, which is instead of being mobile in a vehicle is walking. And there's some people who are really into pedestrian mobile. And of course, they have to cobble together their equipment to make it work. It turns out on the left is my KX2. If you turn it this way, it pretty much fits in your hand like a HT would. And you can have a short whip. This one has, I think it's a loaded whip. You can also get those from MFJ. Actually, Elecraft sells one also. But anyway, importantly, there's like a 13-foot wire that's tied to the ground of the rig. And as you walk around, that wire drags on the ground. And works great. So if you want to operate and walk, if that's your thing, it's pretty nice to do this along the saltwater shore. And the one of the principals in Elecraft likes this kind of operation. So he had to come out with another Elecraft radio. It's called the KH1. And it is similar, maybe a little like it to the KX2, but it's kind of optimized for this pedestrian mobile, what he calls adventure radio. And the whip on it collapses down to about 6 inches. But the coil is integrated into the tuner. Now, this kind of operation works best when your radio has a tuner, because working with shortened antennas and walking around and going over different terrain, the impedance of the antenna and counterpoise would vary a lot. So, but you can just press the tune button and then it's good. So, and speaking of saltwater, the antenna on the left is a vertical by N6 BT. It's called a Bravo 7K, and I love to put it right over the saltwater in Northwest Florida. And I've always heard about the saltwater effect or the saltwater amplifier, and I am a believer. And I did an experiment with whisper beacons, and I did get numbers on it, and you can have a improvement of 10 dB based on where you are near the saltwater. So, and on the right is a magnetic loop antenna, and people, obviously it doesn't look like a vertical, but it is, I believe it has both kinds of polarization, but at the horizon, it is vertically polarized. So I like to use it by the saltwater shore also. So now you can't see the whole antenna here, but I have a different version of the Bravo N6BT Bravo. It's called V8. And in the previous antenna had coils, and you adjusted the lengths of the elements. But this had, you can just use the tuner to make it a multi-band antenna. You don't have to do any physical adjustments. And the tuner is the gray box on this pole here, and it is a LDG remote tuner. and it's powered and controlled through the coax. So it's a very convenient way to have a remote tuner, and the optimum way, if you have a remote vertical that needs a tuner, is to use a remote tuner. And since it is powered through the coax, it really simplifies the installation there. And so this is in my backyard here. I don't currently have it up, but the nice thing, these elements, you can easily, they're collapsible. You can unhook them, and if I wanted to improve the safety for the yard man, I could take the horizontal elements off, and I can take the vertical element down for weather if I wanted to. All right. Well, well, this is a little different, but
Is that that's a jet propel? That's a jet propel vertical?
yeah, it's a solid rocket motor, solid propellant motor. And
So now you have a wire hook. You
well,
have a wire.
if you
You have a
look
wire hook for that?
very carefully to the right of the plume, does anybody see the little wire?
Yeah, I see it.
I
Yeah.
see a very big wire. Yeah.
Well, that is a 30, roughly 32 foot half wave, which would be for 20 meters. So I had a 20-meter HF beacon in the rocket, and so it had a little QRP transmitter, and it had a IDer that sent a CW message, and I got spots on reverse beacon network. And really the one I liked most was a spot from about 40 miles away in Troy, Alabama. So that was basically direct between Samson, Alabama and Troy, Alabama. But with in-fed half waves, you need a counterpoise, but you don't need a quarter wave counterpoise. And this was an example of getting away with little or no counterpoise. So it was just convenient to
How many
drag.
how many seconds was it transmitting for? How long was it up there?
I don't know exactly, but you know,
A big parachute would do
well,
well
the
coming down.
parachute, it's transmitting all the way up, which doesn't take very long, you know.
No, that's like 10 seconds or
And
15
then
seconds, right?
so the hang time is based on how big your chute is, and if you want to recover your rocket. Yes.
Well, that ain't gonna reach Moscow though.
The rocket won't, but the signal will. Now, why would anybody do this? I don't know. But actually, I did a similar experiment with whisper beacons, a whisper beacon in the rocket and a whisper beacon on the ground. It was similar to the saltwater experiment. But
really?
Yeah, well, that's what I was doing while you were out there, Chris. I don't think the second time I did it went as smoothly as the first, but I was able to collect data and compare an antenna on the ground with the one in the rocket at altitude.
Really?
Yeah.
Actually, in theory, only the ground wave would benefit tremendously, I would think, eh? Or what do you think?
I don't think, I don't remember now, but I'll have to see if I can find the results on that.
You know what? If 10 meters opens up this winter, we should try it again on 10.
Sure. I've kind of had my hands off the rockets lately, but um, but the grandkids need to have that rocket experience, so that's probably what I'll be doing. But nevertheless,
Samson, here we come.
yeah, now I didn't provide a picture, but I launched a balloon, and it went up to about I don't know, 38,000 feet, and the little beacon actually had a vertical dipole that was hanging from the balloon, and the transmitter was at the center. So, and that was on 2 meters, and it, yeah, there's a big advantage on 2 meters being that high. So, which is another story. Yes, Frank.
Go ahead. I was just going to elaborate a little bit on tuners, but you got more subject matter there.
Okay.
Go ahead.
Well, now if you're shopping, now we say you always have to have a counterpoise, but you'll find ads for no counterpoise, or it may say no radial verticals. And that makes it very attractive. And I'm not going to say that they do or do not work, but I believe that some of them will work. But basically, I think it's been mentioned that if you don't have anything from your else for a counterpoise, probably your coax will be the counterpoise. And that's what some of these no radial verticals might do. And it's really on a case by case basis. And some of these verticals may actually be an off-center fed dipole or an in-fed dipole. So I'm just going to say your mileage may vary. I actually have some examples of verticals that don't have any radials in the next few slides. But I've had discussions with many folks about, does an in-fed half wave need a counterpoise, or how much of a counterpoise? And there are people that believe that in-fed antennas won't work without a quarter wave counterpoise. Well, that's a battle we won't do tonight, but I did research on it, and the technical types will tell you that you only need about 5% of the wavelength at the lowest frequency. So anyway, so a half wave needs less of a counterpoise than a quarter wave. That's what Greg says. Now, actually, this is related to the J-pole antennas that we usually use at VHF, but it is a 10-meter version of a J-pole, and it doesn't have a counterpoise, although it has a matching section. So the people that insist that it has a counterpoise will say the matching section is counterpoise, but nevertheless, I don't have a bunch of I have built this antenna, and I don't have a bunch of radials or a screen under it or anything else. So this is a good homebrew project. And if you ever run across a opportunity to hear John Portune, W6NBC, talk, he always has something innovative to talk about. And in California, where he lives, he built a essentially flagpole, vertical, which actually is in the ground, but is not grounded. And it's actually an off-center fed dipole, and works fine for him. And he actually uses a tuner in the shack. So this is built out of those, what I call camo poles, the military surplus camo poles. And he's using a combination of aluminum camo poles and fiberglass. The fiberglass will be a insulator. So anyway, if you're in a HOA and you want to implement a multi-band flagpole antenna, you can find details about this on the web. So it's pretty good. All right, another antenna manufacturer. An antenna manufacturer is Step IR. They make Yagis and verticals, and actually their antennas, they basically changed the length of the radiator. It's essentially a tape, a conductive tape that they roll up. That's not a very good description, but they can reel it up or push it out in a hollow tube to change the band. And well, anyway, when I did a Google search, there was a pretty informative info sheet that they provided by Mike Mertel, K7IR. And I stole a couple of tables out of it. And this is a pretty good summary for ground mounting. So their antennas, you may want to ground mount it. And they have some recommendations. They say the radials are non-resonant, so a 0.1 wavelength minimum at the lowest frequency works on all frequencies. So when you are putting wires under the earth, you don't have to worry about if they're a quarter wave, because they're essentially a non-resonant system. And and also they don't have to be as long as a quarter wave. So you'll see different recommendations. In fact, at the bottom, their suggestion is 16.1 wavelength radials. And they say that's enough to give you 65 to 70% efficiency. So if you want to follow their recommendations, that should be all good. Now, I found it interesting on the right side under disadvantages. It said for a ground mounted system, it takes 120 radials. Well, there's a different way of reading this. It says it would take 128 radials to equal the elevated vertical with 2 resonant radials. So you might let that sink in, that if you have elevated resonant radials, it's very efficient. If you use a ground mounted vertical using the earth and wires under the earth, it would take a lot of radials to equal the elevated vertical. Now, one may be more convenient than the other, but you're probably going to get the best efficiency from resonant radials. And that's what Chris does, and what I've done with a buddy pole and all that. So,
Hmm.
uh,
How does the cyclone fence fall in that category?
it's somewhere between, I don't know.
That's an interesting point because it is it's elevated and it's not elevated. Which way would it fly? That's a good question, Frank. I don't know.
Yeah. Well,
You
I
need
mean, I
to
got
do
so
some
much.
experiment there.
Well, it's not resident, I'm sure, but at least it has a whole lot of surface.
Yeah.
Yeah.
But
Yeah,
part of it
yeah.
is elevated. So
Yeah.
what category does it go in? The left one or the right one? That's interesting.
Yeah, right. That's what I was just wondering. Throw a wrench in the works there.
It's a third option.
Yeah.
Well, you can be as creative as you want, and Frank is really creative. So, and it works, which is the beauty of it.
I'm just
Yeah.
hyper. I'm just hyper.
He
Gotta
just
keep it
he
turned
just
out.
wants something to do, is what it
Well,
is.
Yeah.
if I had a metal fence, I wouldn't hesitate to
Yeah,
use it. Absolutely.
yeah. The next slide talks about elevated mounting, and it puts on the advantage side greater 90% efficiency with 2 quarter wavelength radials. And if your antenna is elevated, it may be more in the clear. They mentioned if you have a metal roof, you could use that. And it says you don't have to be elevated very high or whatever. The trick is you want, if you're using elevated radials, you don't want people running into them and being decapitated at night. Or
That's the problem with elevated radios.
yeah,
Like
Yeah,
on 20 meters, I go 3 feet, or 4 feet, whatever those driveway markers are. And man, deers, dogs, kids, you
Yeah.
gotta mind your P's and Q's. That's
yeah.
nothing
So
works perfect.
so it's a trade-off. And as hams, we are the chief engineer of our station and antennas, and we get to evaluate these trade-offs and make a decision. And then if we don't like it, we can try something else. So
Yeah, there's one thing they don't tell you in the books, or if they do, they don't tell you very often. Especially here in Florida where we have the sandy soil. The actual ground, as far as that we're talking about for RF, could be as deep as 2 feet under the surface of the land because of the loose soil and everything that we have. So even one laying on the ground might be considered elevated.
Oh, yeah.
yeah,
Yeah.
yeah,
And the sand is basically glass. So that's a good insulator.
yeah. I've
Yeah.
as I've said a lot, sometimes I throw out the radial just on the ground, and it might not be the best impedance match, but if you have a tuner, then that takes care of it. So
now that you mentioned tuner, do you have any more stuff to say, or
well, I'm pretty close, and we'll
no,
switch
go ahead.
over to
No,
you. We'll switch
no,
over.
that's all right. You go ahead.
Okay. Well, if you want to do a deep dive on the trade-offs, they're covered very well in the ARRL antenna book. And I'm probably in the ARRL handbook also. And so if you really want to get into it, well, I recommend that folks have the antenna book in any case, but they cover it, the technical side of it, in a much more detailed and rigorous fashion than what I've been saying tonight. But anyway, so a plug for the antenna book. There's also a lot of other antenna books that you can buy. And final thoughts, and we'll get to Frank in just a moment. you have to provide the other half of the verticals somehow, no matter what you call the other half. And I don't think there's any particular, the terms seem to be for amateur radio interchangeable. And as we've noted, as few as 2 quarter wave radials can make an efficient counterpoise. So verticals may be the answer for a small lot or an HOA. You may want to do a flagpole vertical. And they make good portable antennas for POTA, parks on the air, and similar activities. So we're going to stop our share and go to our audience here for further comments. Go ahead, Frank. You had a comment about the
Hey,
tuners.
we lost some people. We lost somebody.
When you were commenting about tuners,
Yeah,
my favorite tuner is LDG Z11 Pro 2. And this thing here, it's got batteries in it, so it's standalone. You don't have to
right.
plug it. And then it has an automatic mode. And if you set it outside, when it sees a mismatch, it just takes off on its own and starts to tune. So what I have it is, I have it in, first I have to set it here, so it's on the automatic mode. And then I put it in this pouch that I found at Goodwill, and it's waterproof. And I'll stick it in the pouch, and the little Velcro's there, so it'll fall out like this. And then I'll put my feed coax to the radio to one side, and then on the other side, I'll either have this thing here that I made that'll screw into the back of that, and you can put those whips on each side on top of this plastic here. And then this thing here, I just hang it. I have this pole here, and I just hang it. I just clip it on there. This, and then it just hang there like that. And that's it. I just set it out there. I key up, and that thing just tunes by itself. You just key up, and
Right.
it goes cranking away and tunes.
Well,
So I just thought I'd mention that.
yeah,
Perfect.
That's a
they have a
C11
lot
Pro
of
2.
different, several different models, and
It's C11 Pro
basically
2 is
probably what I have is the same tuner, just in a different, in a
Yeah.
weatherproof box. So
Yeah,
yeah.
that one requires external power. This has a power with it, so you
batteries.
could just
Yeah,
batteries in it. Yeah, so it and the batteries last a year or more.
yeah,
It does. Another thing I want to mention is that these tuners, they have latching relays. A lot of people don't understand what that is. These tuners, when they start tuning, a bunch of relays click in to combine coils and capacitors. And the relays, most of the tuners require energy to keep them pulled in. So to have those energized is sucking up batteries. Where this one here has a permanent magnets. So when it pulls it one way or the other, it doesn't require any energy to hold them in. And those things, it doesn't draw any current at all. It only uses the current when it's tuning. So
yeah.
that's why. So that's the difference between regular relays and latching relays. So real efficient ones have latching relays.
Well, Jimmy, I realize that was a long answer, but did it produce any more clarity about counterpoises and radials?
Exactly what happened. The 741, 844.
I'm going to leave, guys.
Clear as mud.
Clear as mud.
You can
Then
see his,
No,
we'll call that a
actually, yes, it was very
success.
informative. It was very informative.
you can see his eyeballs going around like this.
Yeah. And
Jimmy
actually,
was asleep for the last hour.
yeah.
I do it again. Do it again, Greg.
He should be okay. We didn't ask him to do any math.
Yeah, yeah.
Well, 468 over the frequency and megahertz there. So,
I've got that one. I understand that one.
well, really, if there's nothing else you remember about taking the test, that's
From the acoustic warfare research
that is gold. Of course, for a quarter wave, would be half that length. Yeah, awesome.
about 6%
Ah,
perhaps.
Well, I'm gonna let you guys go. I got
Yeah.
a couple of things I gotta take care of.
okay.
It was a nice program tonight.
Yeah. Well,
I
we
enjoyed it.
covered a lot of ground and we had a lot of contributions to it tonight. Do we have anything else before we
Now you begin
close up shop?